Hello everyone and welcome back to this video. So today we're going to take a look at Spring integration, what it can do for us and what pitfalls it might have. But without further ado, let's dive in. So Spring integration is based on so-called enterprise integration patterns, which we see here. And these are patterns which are in total 65 patterns, which to me looks a little bit complicated. And this is what I like to call a gas factory, a very complicated solution. But hey, there are people who think this is important and that it's needed. However, as it turns out, if you strip it down to its core, it can be pretty simple, because at its core, we just have this. So basically, we just have the pattern of a producer, consumer, and a message channel, or as we would say, publish, subscribe. So this is a very basic pattern of decoupling system by just having messages between them at its core. One of the first pitfall I met was that you can configure your stuff in a lot of different ways. There is the possibility to have XML configuration, which I thought has been long dead. That is one option, and these things can get very convoluted very fast. Then there is the option to do the same for this output channel adapter via annotations with Java, which is at least a little bit better. But as we see here, suddenly our thing that is called outbound channel adapter is now a service activator. I don't know why. And the preferred way to do it is to use the so-called DSL, which you see here. Okay, what we need to do to bring in Spring integration is pretty simple. We need obviously Spring integration. And then for every use case you want to have, we will see this later. For example, if you want to have a file or JDBC or HTTP, we have to bring in a specific dependency. For database, it's very important that obviously you need some kind of database. I'm using H2 here. And you also need to bring in Spring Boot Starter JDBC. Important part, Spring Boot. If you don't do this, you will not have auto configuration, and you will not have auto configuration for the data sources, and you would have to construct your data sources yourself instead of just having a simple URL and the configuration will be done for you. Please keep this in mind, because at least for me, this was not obvious. So Spring integration is a Spring project and not a Spring Boot project. So let's now take a look at one of the first configuration, which is called a simple configuration. To activate this configuration, we have put a profile here, simple, and you can put this here in profiles active. Simple configuration, as it turns out, is the most simple configuration, very obvious. So let's start and see what this guy is doing. So it's bootstrapping our application, and it will just say got message, hello world. So this is the most basic example. Let's take a look how this works. So we have different components here. So first we have our so-called input flow. If we remember our graphics from before, we have producer, a consumer, and a message channel. So this guy is basically our producer. We say integration flow from, and this is the first important part. Everything in the from here is a so-called message source. They are also called input adapters, but this is the most basic thing you can have. A message source with one method, and this will basically generate a new message. We say new generic message here. So every time we get into this integration flow, it will generate a new message. There is a trigger here. So when will we generate a message? And this is basically a Boolean, and the Boolean is always true. So it will always generate a message. Of course, if we would say false, it will never. And we could also trigger this from the outside. One more important thing is that we have a poller here. So this thing is executed once every 1,000 seconds. Don't be fooled if you just strip away this configuration. This thing is still a poller. It will just configure this standardly with 100 milliseconds, but this will still do polling here. One very important thing. And then with this flow, which will basically just generate a message, we connect this to a channel. I call this a simple channel, and this channel is a queue channel. There are a lot of different channels here. The standard type is direct channel. However, direct channel is not going to work if you want to directly send a message to the channel, which you could. Then you have to use the queue channel. I don't know why, but if we want to have the use case that we want to send a message by ourselves, which we usually won't have, you have a queue channel. Otherwise, you're good to go with the direct channel standard. So connect this to the simple channel. And this is the first part of the configuration. On the other side, where we configure the output, we now say integration flow from. We connect this to our channel. So not like here, where we connect it to our message source. We connect this to our channel. And then the next important thing, we handle this by a so-called message handler. Again, that's a very simple interface, which just says handle message, and then we can log our message that is received, so our generic message. Let's see that again in action, just to get a better understanding. And we will see we have our producer at the top that generates the message, and we have our consumer, which consumes the message. And this is the most basic flow. We can, if we want, optimize that. You see, this is already gray. We can reduce this to a lambda. So it will be shorter. We can reduce this to a lambda. And then what's also very important, it's not necessary to have this output flow. If we want, we can strip this away and we can simply have the handle method here. And we can strip this and it will still be working. At least I hope so. Yeah, still working. And as this is now mostly intrinsic, so we directly connect producer and consumer, and there is also no need anymore to have the channel here, and this should still be working. So this is the most basic flow that you can get here. Let's revert this, and then let's go to the next one. So next up, we have a so-called file configuration. This is basically reading files from a directory and copying these files to an output directory. So yeah, let's go to my downloads folder. We have Hello World here. Let's remove this. And let's see what will happen. So I say profile active is now file. Start our application. And then it should do something. So it already copied Hello World. I will just rename Hello World. And no, not like this. I will just rename Hello World to this, and then it should generate a new file. And I can again rename this, and it should generate a new file. So let's take a closer look at this kind of configuration, how this is working. Again, we have an input and an output. In this case, the message source is a pre-existing so-called inbound adapter. This needs an input dir and needs a file pattern. So input dir is downloads inbound. File pattern is just everything. And then again, we say integration flow from message source. We have our poller here. We have our channel here. One of the first differences is that we also need a transformer here. Honestly, this transformer is optional, at least for this use case. It will convert the files to strings. So this is also one of the more important constructs that we can use. If we need to transform our input to something else, we can use a transformer. We can use a transformer on our own, or we can just use a pre-configured, and this will just convert the files to strings. On the other side, we have the outbound adapter, which again receives the messages from our file channel, which is now a direct channel here. And it delegates this to the message handler, which is basically a files.output adapter. it has some configuration like the output dir, and then it will just do what we saw. It will copy the files over. Okay, next up, JDBC. For this, we have an H2 database and we have some demo data here. So we have Boomer, Bart, and Monty Birds. Let's first, of course, we have to change our profile again. JDBC. Bring this up. Okay. And now we see that it's basically logging the data that it's reading from the database. So we have a list here. Let's stop this so that we can inspect this at a closer look. Yeah, thank you for that. So we have Homer Simpson, we have Bart Simpson here, and we have Monty Birds here. So this is the most basic thing you can do when you want to read databases. How is that working? So again, we have a message source, which in this case is a so-called JDBC polling channel adapter. This is configured every 1000 milliseconds. So every second it will just do a select. It will read the data. It will not convert the data to anything. And it will just put that to the JDBC channel, and the JDBC channel will just log out the payload from the messages. So if we post messages from one channel to the other producer, the information will just get passed into the so-called payload. And in this case, it's a list. So with the simple use cases being done, let's now take a look at the more complicated or complex use cases. So our first one is the so-called person anonymizer batch configuration. This is an example I carried over from my Spring Batch example. So we will now say active profiles batch. Then we will start our application. And we will take a look at in a minute. So this thing is basically reading the person information we saw before, and it will customize this. So it will update the configuration where we now will see here, first name and last name get fake. How is this working? So again, we have our reader here, our JDBC polling channel adapter we saw before, but now there are some changes. First and foremost, as we are now dealing with an object here, which is person, and not just flat lists, we need to set a row mapper so that this will be converted to a person object. And we just can say bean property row mapper, and this will automatically map the data from the database to our bean. We have again a poller here. And now we also have a so-called transformer we saw before, but this is our old transformer. And this transformer will do the anonymization. So the transformer, which is an abstract payload transformer, has one interface method to implement, which is transform payload. It will get a list. And then we will just delegate this to this process method, which will update everything. So this is already very similar to what we have in batch. We have a reader. We can have some kind of transformer or processor, as it's called in Spring Batch. And then, of course, we need to have a writer. So for the writer, we connect everything to this JDBC channel. And the writer is, again, also just an integration flow, which will receive data from the JDBC channel, and it will handle the messages. So it needs an update statement to update the data. And it will just do, we see here, named JDBC parameter template, which you can inject. It will just do a batch update of the information received. Now you might wonder why I'm using named JDBC template here and not using an outbound adapter or a message handler, as they are called here. Yeah, you see this comment here. I wasn't able to get this working. I read a lot of information on the internet, and the documentation was somehow all over the place, and it was just not working. But to be honest, this also works. So you can just have a JDBC template, and you can have your manual writer, and then this will become your output. And this is one of the nice things of Spring, that you can combine a lot of things with a lot of things. So yeah, this is the reason here. Okay, that's the batch processing. Next up, we will take a look at some servers, because we can also program services with Spring integration. Does it make sense? I don't know, but if we want to, it's possible. So we can take a look at this guy here. So this is our profile service. Yeah, so we need to configure our profile here, service. So let's bring this up. And we will get an exception, some kind of mumbo jumbo exception, but that's pretty understandable, because the Corley service configuration, which relies on HTTP, needs some kinds of HTTP implementation, and the easiest way to do this is to bring in Spring Boot Starter Web. Again, also to get some auto configuration here, as we saw with our Spring Boot Starter JDBC. Now it should be working. Running, and obviously it's not doing a lot. So let's now first take a look what it's doing. This thing is receiving data from two inputs, from two methods, call is say my name and call is say my other name. So now I have to go to my terminal, and then we just have a curl request here. Curl. Okay. Yeah. And then we say curl HTTP localhost call is say my name, name yo, and you see now your name is yo. And if we would do the other call, so the same my other name, this should also work. Yeah, your name is yo. Okay, it's the same. I should change the output of the configuration, but this is working. And how is this working? So basically, we have again integration flow here with the so-called inbound channel adapter. Then we say which method it should react to. So it uses a so-called get method. And then you can also have some parameter here. So our parameter here is, let's take a look. So this is a query param here. And then we will just handle out the message. The payload in this time will be a linked list, and then we can get from this list, can get the name attribute and put it out to the console. Honestly, I did not dig into this too much, because does it make sense to build services with Spring integration? Probably not. It could be beneficial if you need as an input a REST call and then react on this. But I don't think it makes sense to build services with this, but it's possible. You could then also have an output adapter and put the data to the database. This would be possible, of course. Okay, let's stop this. And now let's take a look at another configuration, the so-called TCP configuration. And honestly, this is where it all started. So we had one very special requirement where we needed to receive TCP data on the background, and then we need to convert this to a WebSocket, because receiving TCP data is something you would usually not do nowadays, but there was a requirement for this. And this is, if you look up Spring integration, one of the most common use cases, because Spring does not have a TCP adapter. And no controller. So there is no controller for TCP, but Spring integration can help you here. Before I start babbling too much, let's bring this thing up and let's see what it's doing. So this will now register a TCP adapter for an inbound on port 5100. And we have again to go to our console. So what we now do is we echo this hello \r\n, that's important in this case, and we send this via NC. Okay, now we should get a message here. We say got message hello. So this way we are able to receive ancient TCP data. Also say world, and then we should get world. Not that interesting maybe, but if we now go to our web page, we will see, if I do this again on my console, that we receive now on the front end our message we sent via the terminal. And that's the important, that was the required use case here. So we receive TCP data on the back end, and we need this via WebSocket on the front end. And you see this is working nicely. This is working with Stomp. I can say another. And then we get another. So how is this working? Again, we have an inbound adapter here. This is so-called TCP inbound adapter. These need support and also a deserializer, because what's very important, TCP streams are usually bytes, and these need to be serialized. Again, from message source, we need to have a transformer here. Very important, please put the transformer here and not here, because otherwise you will get an exception. We transform our byte to a string, and then we connect an output flow here. Now we have a similar situation like we had previously with our batch. While there is an output flow for WebSockets and even for Stomp, this is super, super complicated. So we are again going for a generic handler here, and also something very similar. We can just do what we would usually do with Spring that you might have seen in my other video. We can bring in a so-called WebSocket config, which is just this guy here, which registered the WebSocket. And also we say enable WebSocket message broker. And then instead of having this very complicated output adapter for Stomp for WebSockets, we can just inject this simple message sending operations, which is basically also a template for sending messages. And then we will just say template convert and send, and this will work and will send this information to our WebSocket with little to nothing configuration. So we receive our message from the TCP send channel, and we send it out to the WebSocket via this template. So that's mostly it for today. One more thing, Spring integration in theory will also support native images. This is working for the simple, for the basic examples, but the moment you bring in web, it's broken. But I haven't verified this any further. But other than that, I hope that you got a nice impression also how to work with Java DSL. It took me honestly a long time to figure out the things I showed you, so I hope it will be of help for you. And yeah, that's so much for today. Thank you, and I hope to see you in the next video. Bye.